The last rule that we're going to talk about in section 10.1 is our power rule for our exponents. Right? And our power rule exponents says that for any non-zero base, if we have x to the a raised to a power of b, we're going to get x to the a times b power. Right? Sometimes this is also referred to as the power of a power rule. Notice that we have one power or exponent inside our parentheses, and we have one power or exponent outside our parentheses. Right? So if we have a monomial, which again we're going to discuss a little bit more in the next section, we have one base in here raised to a power, and that's raised to another power outside. We're going to multiply those exponents. Again, we are not going to change our base. So if we, for example, think about the expression 3 squared to the third power, that means that we're going to repeat 3 squared 3 times. Okay? So we have 3 squared times 3 squared times 3 squared. Right? Well, now that we have this written out as a product, we can use our product rule that we just talked about in the previous example. If we add these exponents, 2 plus 2 plus 2, that gives us 6. Right? But instead of rewriting out this product every time, right, we're going to use our shortcut. We're going to say we're going to take these two exponents, we're going to multiply them, and that gives us our answer of 6. Right, same thing is true if we have a variable for a base. X cubed to the fourth power means we have 4 factors of x cubed. So x cubed times x cubed times x cubed times x cubed. Again, using our product rule from the last example, 3 plus 3 plus 3 plus 3 gives us 12. Right? But instead of writing out and doing all that addition, we're just going to take the simple shortcut of multiplying that 3 times 4 to give us 12. Right, so now let's do a few examples using our power rule. Right, c to the 6th squared, right, means we have 2 factors of c to the 6th. Again, we could write it out, or we could use our shortcut. 6 times 2 gives us 12. So we have c to the 12th power. Right, we have 2 to the 7th to the 5th power. Means we have 5 factors of 2 to the 7th. Again, we could write them out, or we could do a quick multiplication. Our base stays 2. 7 times 5 gives us 35. Right, y squared to the 4th power means we have 4 factors of y squared. 2 times 4 is going to give us 8. Right, for d, we have d to the 5th to the 1st power. That means we have 1 factor of d to the 5th. Well, 1 factor of d to the 5th is just d to the 5th, right? Because anything to the 1st power is itself. Or if we use our power rule, well, 5 times 1 is still 5. So either way we think about it, we get the same answer. Right? Something similar happens for e. We can think about this a couple of different ways. We could think about this using our 0 power rule. Anything raised to the 0 power is equal to 1. Or we could think about this as using our power rule in this section. Right? 2 times 0 is 0. So q to the 0 is also equal to 1. Right, so feel free to jump to the answer right away or write out the variable or number to a 0 power in between. Just remember as you're going through and working on your homework, anytime we have anything to a 0 power, we don't want to see a 0 power in our final answer. We want anything to the 0 power, in this case our q to the 0 power, to be reduced or simplified to the number 1. Right, so our power rule for exponents again tells us if we have a power raised to another power, right, we have an exponent both inside and outside our parentheses, we are going to multiply our exponent.